So it is now time for our first academic session of Soiree 2024. And to host this session, we have Education Committee member William Barres. William, thanks for hosting the session. I'll leave it to you, and I'll just deactivate my camera and microphone and enjoy the presentations.
Okay, welcome everyone to the Soiree winter session on XR methodologies. In this session, we have three presentations, and the format will be each presenter will be briefly introduced, and we'll have 5 minutes to introduce their work. And then after the three presenters have each had their approximately 5 minutes, we'll then have time open for conversation. And the session is scheduled to wrap up at 10:20 a.m. Pacific Standard Time, or 1:20 p.m. East Coast Time. Okay, so thank you for joining us and welcome. So our first presentation will be by Krishnan Chandran from Technical University of Dresden. Krishnan, please get ready to share your screen, and I'm going to step aside and let you share your work.
All right, thank you so much. Okay, so let me start by sharing my screen. All right, hello everyone. My name is Krishnan Chandran. I'm a research associate in the Immersive Experience Lab at the Technical University of Dresden. The lab is headed by Professor Matthew McGinnity, and today I'll share some insights from our research pedagogical practices in co-located mixed reality classrooms. The work is based on a series of case studies that we conducted in last year, 2023, from June to August. So before we move on any further, let's try to define what we are talking about when we mean co-located mixed reality, because mixed reality is often defined in a variety of ways in literature. For our context, we define co-located mixed reality as the following. So we are mainly concerned with systems where multiple individuals are involved wearing HMVs, and they engage in a natural and direct communication. And they also engage with real and virtual content, for example, by using physical affordances. And lastly, the experience takes place in a shared mixed reality environment. So this environment should be synchronized and consistent between users. So in this case, the environment would be a mixed reality classroom. So the unique spatial features of co-located mixed reality offers really novel ways of augmenting and interacting with the surroundings. And also, it makes it possible for us to be in a shared virtual environment. So being a relatively new medium, this also requires new ways of thinking and planning educational experiences. So we were primarily interested in identifying what kind of pedagogical practices would emerge in such co-located mixed reality classrooms. So primarily, we had two research questions. What are the pedagogical opportunities in co-located mixed reality classrooms, and what are the challenges? To answer them, we conducted 4 case studies involving senior lecturers and university professors, with practicing professors giving immersive lectures to active students. The lectures lasted from 30 to 45 minutes and included a variety of topics like linguistics, cartography, geomorphology, and learning environment design. We wanted to identify what pedagogical practices can these such co-located mixed reality environments facilitate. So we started off by developing a digital twin of 11 cross 12 meter space. All the lecture material was developed using our open source framework, which is based on Unity. The software took care of calibration, co-location, and mixed reality blending. We started each of the case study with a familiarization session where the educator was invited to the space and a basic introduction was given. Early impressions were collected. We allowed strict budget of time to avoid the development to explore. And then we conducted 2-hour-long participatory design sessions with the educators, where we ideated the lecture essentially. So the idea there was to take an existing lecture and build upon the expertise that the educators already have, and to convert this to an experimental mixed reality lecture rather than creating an entirely new lecture from scratch. So the outcomes of these sessions were a series of sketches, a storyboard, and a spatio-temporal layout where the lecture was sequenced spatially and temporally. We set ourselves a hard constraint of 1 week of content development with a team of 2 developers and 1 3D modeler. And in the next session, the instructors delivered the mixed lecture to a student set of their choice. In a mixed method study procedure, we employed interviews, questionnaires, and recorded lectures to gather insights from the educators and the students. As mentioned earlier, in these lectures, we wanted to explore the emergence of pedagogical practices. So, for example, in the lecture Language and Space, the primary topic of discussion was spatial perception and how it relates to language. The Origo model of linguistic deixis was introduced in a series of spatial orientation exercises. Students also leveraged the spatiality offered by the mixed reality environments. So here, the students are using the environment as a canvas to collaboratively model things and annotate on it. A full recording of the lecture is available online if it's of interest. In the lecture History of Cartography, the educator traced the evolution of map making. So from the historical mammoth tusk to the state-of-the-art in cartography. The lecture also involved a series of map interpretation exercise, where the students are tasked to identify a known location in a historical map, and then they have to analyze it. And additionally, the lecture also had interactive tools for Mercator projection and circumference calculation. Finally, the lecture ended with an interactive panorama projector where a 360 view could be projected to the mixed reality environment. In the lecture Understanding Landforms, the goal was to use mapping, imagery, and virtual models to understand geomorphology. So students performed a treasure hunt-like exercise to map the corresponding contour photographs and the descriptions. So here we're talking about how spatial linkage can improve cognition. And in the lecture also consisted a virtual sculpting exercise where the students would try to sculpt an arbitrary terrain, and they would discuss the morphological feasibility of such a terrain existing with the instructor. And in the lecture Design of Learning Environments, we explored the idea of context-based learning exercises. So to summarize, over 7+ hours of interviews provided valuable insights into the challenges and opportunities of co-located mixed reality lectures. We categorized the pedagogical opportunities into 6 categories. At the same time, we also identify significant challenges surrounding content creation, workload management, student engagement, and user interaction. So to conclude, although the hardware improvements are continuing, making multi-user mixed reality more and more accessible, practical difficulties exist in planning, designing, and managing these mixed reality lectures. So that's it from me. I'm happy to elaborate on any of these points in the Q&A.
Thank you very much, Krishnan. Okay, we will continue with our next presentation. And the next presentation is by Beatriz and Bernardo from University of Aveiro in Portugal.
Okay. So good afternoon, everyone, or good morning.
Beatriz, you're not seeing the slides. You have to share.
I'm sharing the slides.
Yeah, but not in presentation mode.
Oh. Okay.
It's just because of the videos.
Oh, that's right. You are right. So good afternoon. And I'm Beatriz. We have Bernardo here with us also, and Paulo. We have been teaching a course for 10 years now at an engineering department. We work in a public Portuguese university, which is mostly devoted to engineering and science. And we are focusing our presentation in the assignments that we have been doing with our students. But before that, and Bernardo is going to show you some samples. But before that, let me give you some facts on the course. So it is offered to mainly engineering students, several different engineering programs, informatics, computer engineers, electronics engineers, biomedical, and also other types of programs as robotics and intelligent systems in game development. So we have many different profiles with different backgrounds, motivations, and also programming skills. It's a typical elective course with sessions, 3-hour-long sessions that usually we divide in 1-hour lecture, half an hour of paper presentation and discussion, and then a lab class where the students develop their works, their practical assignments. The papers usually are selected by the students from conferences that we indicate, mainly IEEE or ACM, very good quality conferences, but they are free to select in the paper, and we ask them to present as if they were at the conference, and then we organize a discussion. Well, the assignments usually are performed by groups of 2 students, and the assignments and also the topics that we address have been, of course, evolving a lot along these 10 years. We now devote more time, and the approach is more on system development and less on, for instance, geometric modeling, that as it was when we began in 2013. We have a lab. We try to acquire and have some, well, state-of-the-art, as much as possible. We keep equipment, hardware, but that's a bit of a problem. But we have been tackling this reasonably, I suppose. The course is very popular, and we had to increase the number of students every year. But at the moment we have 22 students at most. Now, Bernardo, the floor is yours. Please give some details on some of these works that we selected to showcase the practical assignments that our students have been doing, maybe more in the latest editions of the course.
Yeah, thank you, Beatriz. So greetings, everyone. So here you can see some representative works created over the last 5 years, more or less, using both virtual reality and augmented reality. These works were associated with students' dissertations or were selected by the students since they were a topic of their own interests. On the top left, for example, we can start there. You can see the work of the students that explored how to represent air pollution in virtual reality environment. This was used to raise awareness, or, for example, during student visits, which illustrates an important topic nowadays. So this was a collaboration with the environment department here at our university, and we believe that this represents also a contribution to society. So another contribution to society, very important, is associated with the bottom left, with the bottom left actually, where you can see a virtual reality serious game used for helping persons that suffer from stroke. So here we represented or we created a serious game, which we can see the supermarket, where the stroke survivors would need to conduct specific gestures following literature on the subject. So moving on the top right corners, you can see here some works regarding entertainment. These works are not so specific as the other ones. They do not represent a specific contribution to society or something like that. They were selected by the students just as a way to create some space, some entertaining environment where anyone could have a good time. So we have on the center a specific escape room in which the students spend a lot of work and a lot of time creating an environment where you are inside an apartment and you have to find specific cues all interconnected with each other in moving from space to space and until you are able to free yourself. So on the other hand, on the right side, you have a specific cube, and each face of the cubes has a different game, all of which are also interconnected, and they have cues which you will have to use on the next game. So the last two works that I'm going to talk a little bit are associated with the topic of augmented reality. In this case, one of the works is based on the collaboration that we have with the Bosch factory here in Aveiro. And the idea is that we can use augmented reality in a continuous way without the need for markers. And this way we can help, for example, an operator that is responsible for a specific machine, allowing him or her to have a representation and a visualization of specific data. This data is obtained in real time from an API that is provided from the factory itself. So, and the last work also represents the use of augmented reality, in this case using a handheld device, as you can see, for example, to control a robotic arm. The idea is that we have a virtual replica that can be controlled by the user. In this case, it could be an operator also in the factory, and you are also seeing a safety zones. The idea of the safety zones is that there is no possibility to interact with the robot when you are inside these safety zones, because the space is not safe for you to be in there. So you have to step back, and then you can control the robotic arm. This way, by using also a virtual replica, it also allows a remote user, for example, to teleoperate this robotic arm. So really quick, just to finish up, as you can see here, we have different works. Besides the works that address an entertainment mostly focused, all the other works have a specific purpose. This has been an effort that we have also been done in the recent years, having topics of work and trying to establish a connection with other departments or other entities that we usually collaborate, allowing the students to have a specific work in which they can contribute to society, and which they can see that their work has a specific purposes and can help different audiences. So, and with this, finish my presentation and also Beatrice's presentation. Thank you all for your attention.
Okay, wonderful. Thank you very much, Beatriz and Bernardo. We're going to move on to our third and final presentation for this session. Birte Heinemann joins us from RWTH Aachen University in Germany. Birte, please share your presentation with us.
Yeah. Okay, that should work. Hi, I'm Birte Heinemann from the RWTH Aachen University. The project I show is mainly mine and Sergei Gersten's, who could also be online, I'm not sure, and our Professor Schröder. And in our learning application, which we named Repix VR for rendering pipeline experience in VR, we teach the very basic ideas of the rendering pipeline. So we talk with the students about vertices and triangles, about objects in 3D space, how to create light and shadow, and, for example, textures, and all in all, how to create digital images and 5 minutes are way too short to show the application, because you already heard there are multiple steps. So I will tell you what we want to do. We want to introduce simple ideas and introduce concepts like we already heard in the Houdini session. And we want to do it in a very short time. So we try to motivate the students and to show them what's the fascination of doing something in 3D, and provide an easy access to all of the different topics and all the steps of a rendering pipeline. And we want to teach them in an interactive and tangible way, and also help them to overcome the fear of mathematics in computer graphics, and to give them an overview about the whole rendering pipeline in a short time. And last but not least, we want also to learn about learning, because I'm from the Learning Technologies Research Chair. And to evaluate this application, we used it, for example, in the introductory computer graphics course with Professor Koppelt from our university, and also already in some other contexts. So up to now, we have nearly 300 learners learning with our application. And we do not only use questionnaires to evaluate it, but we also use learning analytics to evaluate data we collected while they used it, and try to find out how to create a really good learning application. And the overall design process we use is a mixture between design-based research and design, make, learn cycles. So it's agile and iteratively developed. So now about the content. So in a nutshell, we have 9 different stages, and in the beginning there's a tutorial. We have an application stage. We teach something about 3D geometry, about 3D transformation and perspective transformations. There is number 4 is clipping, and we show them what's clipped, rasterization. Then there's the light bulb, and that's local lighting. We teach about texturing and visibility test, and in the end they can try out and put all of it together. There's not enough time to show you a whole demonstration, but here's a video. And oh, I'm not sure, do you hear the music? Okay, that's good, because I want to talk about it and you should not hear it. So you can see, for example, here the application stage, and our student Jasmine is trying to learn about it. That first was an animated version, and this is an interactive version where they try to build a solar system, the students. And in the end, there is the Earth flying around the sun. And that's the 3D geometry stage where they try to rebuild a polygon, and afterwards they can also play around and test if they are able to create different objects. Now you can see that they are able to move it and to play with the vertices and to check what's going on. The next stage, we'll see a 3D transformation. Let me check the time. I think that's it. Maybe you can see later more from it. So as I already said, we have some interactive and some non-interactive stages. That's also to fit in different curricula. And to be honest, because we are researching what effects interactivity have in such learning applications. So here's also an interactive version again. And I think that were my 5 minutes. So Repix VR is about learning, and it's open source and modular. And we hope maybe someone of you will also use it later.
Thank you very much, Birte, for this really amazing presentation. I mean, you're definitely right. There's so much to cover. And now we have time, about 20 minutes, I believe, for conversation, questions, and answers from everyone. So I'm going to take a look at the chat and see if we have any questions coming up. Okay, lots of likes from folks in the conversation. No questions yet, so I'm going to give folks a moment to think about their questions as we sort of look at it. So I'll go ahead and get started with the first question while folks are thinking about it. So the first question is for Krishnan and co-author Matthew. It's Krishnan, one of the questions I had is in terms of future work, thinking about how you might think about how well did this actually work out? Are there any future plans for how you might compare how the traditional lecture versions of these presentations work in terms of student learning outcomes versus the XR versions of the courses?
Yeah, that's a good question. So we did think of this precise question on how to compare it with the conventional version of the lecture. But I think it wouldn't be that easy to really compare it in a purely objective manner. So at least from our interviews, we most of them, at least a few of them, had kind of already gone through let's say the conventional version of the lecture. So for them, they definitely imagined this kind of like more tangible and more embodied representation of these concepts would have definitely helped them understanding these concepts much better than the conventional version of the lecture. But in terms of future work, so something that was really evident from across, like a common sentiment across all the interviews was like content creation is a huge problem, like with these lectures, because sometimes lecturers would have essentially, sometimes it would be an apprehension about the effort that is required to really conjure up this lecture, but sometimes also the estimation is completely wrong. So this is something that was a big challenge for us. But something that we are immediately looking at is more of a general purpose multi-user mixed reality presentation tool. So in the sense that you should be able to use traditional lecture materials and simply throw it into this platform and still have a mixed reality version of the lecture. So that's something that we are considering immediately.
Thank you, Krishnan. We have two questions in chat, and I'm going to actually start with a question from Nick. Nick's question is directed to both Krishnan and Birte. So since Krishnan, you're currently visible in share, I'm going to give you first go at this. So a question from Nick is, any thoughts on how your approach might be, your two approaches, Krishnan and Birte's work, might be combined to create a hybrid collaborative space for students to learn and experiment with the underlying principles of computer graphics and interaction. So Krishnan, I'll give you first go at this question, and then we'll switch over to Birte to hear Birte's thoughts on Nick's question. And then there's a second question directed towards Birte.
Right. Thank you. Let me have a go at this. So this was exactly what I was thinking when I was listening to Bertie's wonderful talk. So the first thing that came to my mind, okay, what if this was a collaborative space? So definitely that's definitely something that we should consider. But the general idea of using, let's say, all the affordances that immersive media offers to educate computer graphics is, I think that the idea is fantastic, right? Because often I think of maybe anyone who's been involved in either math or computer science education would have encountered this thought. The the underlying representation and what we interact are often a little bit different. So take for example, a math analogy here. The equations are completely different from what you kind of interact, right? And then you, as students, we are constantly interacting with the representation, so the equation form, but not so much with the form, right? So and then being able to interact with the form directly, it's a sometimes it's like an eye opener for students.
Thank you, Krishnan. Birte, would you like to share your thoughts on this question of combining your two projects?
Since the beginning, we thought about how to gamify it, and often other persons are part of the gamification ideas we had. So a simple, easy one we had was to create something like a famous game in VR, which is Keep Talking and Nobody Explodes, where someone is in VR and other people are not in VR, but they need to bring something together. So we thought about a person outside of VR getting a picture and should explain the picture to the other person who tries to create it in VR, because something like the aspect ratio need to be different. It need to be, because it will force students to talk about the contents and to use the terms, because otherwise it's not easy to explain. So something like the bunny should not be part of the picture. That was our first idea, because it's somehow easier to implement, because we do not really need to have it for multiple persons. But our students also told us that they have the idea of seeing what other people created in the 3D geometry stage, for example, where they created these objects, and they are really interested in objects from other students. So we thought about them together doing it, or at least, because it's easier and the programming power is not endless, to give them the opportunity to see what other students did. So do you want to see what others did before you? Do you know someone in your course? So at least something like asynchronic multiple users. But I also love the idea. It would be so nice to have them standing around our objects and talking about it and looking at the pipeline from different angles and talk about it.
Cool. Thank you, Birte. Okay, there's one more question in chat, and this question is for Birte. Birte, this is a question from Rich. What API did you use to implement your system? And second part, is there a link to an open source version?
Yes, we used Unity to implement it. First, we started with SteamVR, but now we try to change everything. So we use Unity XR, and we also use some other open source projects, for example, to enable text-to-speech. So now our robot, the tour host Kyle, he's able to also talk to the students. And recently we had a thesis and he implemented a hint system. So if you need too long to do something, the robot gets the ability to tell, if you're not sure how to do it, here's a hint. So to make it even more personalized. And I will share the link. And we also provide help if there are problems, because we are really interested in people trying it and using it.
Oops. Thank you, Birte. Okay, I'm going to swing the next question over to Beatriz and Bernardo. Beatriz and Bernardo, one question I had is, I mean, these are really such a wonderful variety of different student project examples. So one question I have is, what type of prerequisite knowledge and skills do students typically have coming into this course?
Well, we ask them to have good programming skills. And that's it.
Okay, now programming skills can encompass quite a range of things, from just a computer science 1 class that might be taught in Python, for example, to data structures class in C++.
Usually our students have 2, 3, or 4 courses. The majority of them come from informatics engineering and computer engineering, and those have a very good background in programming, and also human-computer interaction, for instance, which is also important in this course. But people from biomedical engineering or
Game design.
automation or electronic engineering will have maybe 1 or 2 courses in programming. Well, but I suppose they are able to cope with the assignments. Of course, they will have not as well developed assignments as the other students. But since we are using Unity, it's easier for them to, to present a reasonably interesting assignment. On the first years, we were using the visualization toolkit. And well, at that time, we only had students with informatics or computer background.
Okay, thank you, Beatrice. Looking at chat, I don't see lots of thanks for Birte for sharing the link to the GitHub project. So I'm going to ask a follow-up question. So since it sounds like there's a variety of backgrounds that the students are coming from, whenever you form student teams, do you think, as an instructor, consider forming the teams based on the backgrounds of the students to create an interdisciplinary team where each team has a student who has more of a programming background, with a student who has an arts background, and maybe a student who has maybe a content knowledge background? So if you're creating maybe a biology simulation, you maybe have that student who has that biology background. So is there any sort of thought process that you put into deciding how to pair students up or group students when they do their projects?
Yeah, I think I can take this one if Beatrice is okay with that. So usually we already had that discussion, and probably it should be a standard to have students from different subjects and intertwine them to create multidisciplinary teams. But actually we have seen that usually students that have a better understanding and taste for the similar topics, usually it works better. So nowadays what we are trying to do is we let the topics of the work be available and let students see what they want to do, and then we created the subjects based on that. Sometimes you have students that have the same background, sometimes you have different backgrounds. So I guess nowadays we have a mix and match of different types of backgrounds in the same class. Of course, then during the practical classes, we have to try to give some different support, some more personalized approach to each group. So each group will be different on one side because each group have a different subject and different topic, and also because their backgrounds could be very different. But as you have seen on the videos, and there are other videos and other works also very interesting, we have obtained very interesting results, specifically in the latest years. Also, as Beatriz was saying, thanks to the rise of the Unity and all the documentation examples that are available. So we are very happy with what our students have been able to achieve nowadays.
Okay, thank you, Bernardo. I saw a message from Birte in chat asking, I think, to ask a question.
Yes, it's for Krishnan. In the beginning of your talk, you explained how you created the space. Could you elaborate a bit more about it? What software did you use to create that cool space?
So the digital twin itself was modeled in Blender. Yeah, so we took the measurements with a combination of real-world scales and point clouds, and it was hand modeled on top of that on Blender. And then we used the open source framework that I mentioned. And I think it's also shared in the links, but I don't know if it's already shared to the presenters, but if not, I'm just sharing it. So this is the yeah, so this is also open source, so feel free to check it out. And
Thank you, Krishnan, for sharing the link. Okay, we have until 20 minutes after the hour. I believe that's about at least 5 more minutes for questions or further discussion. Okay. Okay. Watching chat.
I'm just going to make sure. I think it looks like the links that got shared went just to the hosts and panelists. So I'm just going to copy paste those 2 links. So the first link I pasted was from Krishnan, and there's another link from Krishnan here, making sure those go in, and a link from Birte. Are those the 3 links?
I shared 2.
You shared 2? All right, let me get to your 2. Here's one. Yes, there's the earlier one. Okay. Ta-da. Okay, so now everybody in the attendee list is able to see those.
Okay. Thanks, Nick, for sharing the links to everyone.
Yep, sorry for the disembodied voice, just being
oh no
person
worries
in the
at
chair
all.
in the background, just trying to help take care of things.
Okay, continuing to check out the chat window.
If there are no more questions, then you know, it's okay to wrap up. You know, we don't have to put everyone on the spot to invent something new. I mean, I think honestly these presentations were fabulous, and along with the follow-up questions as well. And so I really want to say thank you to William for leading this conversation, to Beatriz, Bernardo, Birte, and Krishnan. Really wonderful material. This is exactly what Soiree is all about, is educators sharing with educators. And so I think we'll take an extended break. And just again, thank you all. So I'll pause the recording while we have a break, and we'll reconvene in just under 15 minutes at 30 minutes after the hour for our next session. So thank you, everybody.
Thank you.
Bye.